of your first choice.
All right. Slight change in wording, where you are relative to where you started. How far you traveled would be distance. So if I start here at the, let's go ahead and make to the right positive. I'm gonna make this my starting point. That's P for starting point. And I travel over here, and then I travel back, and then I travel back. Is my displacement positive or negative?
Negative.
Why?
You're going in the opposite direction of positive. So
You're on
this way's positive, this way's negative.
Okay, I would have worded differently, but yeah. Somebody else with slightly different wording?
Did you start from right there?
Sorry?
You started from right there?
I started from right here.
you're on the negative side of the starting point.
Yeah. I'm on the negative side of where I started. What I did in between is irrelevant to my displacement. All I care about is where am I relative to where I started at the moment the question is asked. So at 10 seconds, where am I relative to where I started? How far I actually traveled, that comes down later, but that's not displacement. All right, so we can look at it a couple different ways. But the simplest way, I think, is, let's just relate it to a road trip. Let's say that you're driving from here to some faraway place within the continental US and Canada. You, on average, drive 50 miles per hour for 10 hours. How far have you gone?
500 miles.
Similar type thing here. If on average my velocity is negative 10 meters per second for 10 seconds, where am I relative to where I started?
100 miles, negative 100 miles. I mean meters.
Thank you. Yeah. I just do the average, what my average velocity is times time.
Times what? Time?
Time, yeah.
Okay.
So on average, over those 10 seconds, on average, I went negative 10 meters per second. And so my displacement is just average velocity times time. So typically, I ask for average velocity before displacement. For some reason, I did it the other way around. And by the way, if I give you a problem where I list out a whole bunch of things, let's say there's 10 things that I'm asking you to find, I usually put it in the order in which I solve it. Exception here. If you solve it in a slightly different order, that's fine. Just, if you jump out of turn, just draw an arrow and, make it obvious how you got some of the information. If you need to answer to part A to do part B, and you can't figure out part A, but you know how to do part B, if only you could get A done, make up a number for part A and move on. I'll take off for part A, but your part B will be based upon what you did for part A.
So if I was reading what the triangle, like what the little triangle means, how would I read is that the change in? Or?
It's displacement is change in position.
Okay, so the triangle reads as displacement and is change in position.
So if you have, this could be read as either change in position or as displacement.
Okay.
So it's the symbol for displacement, or if you want to do a more literal change in position, it's identical. There's a question on a master set I asked for 151 where I asked for the displacement, and then the next question is what's the change in position? And it's asking the exact same question. And way too many students miss it. The question's up to here before we tackle the stumbling block for a number of students. All right, so I have some starting point right here. We'll make to the right positive because I start out going in the positive direction. So I'm starting out going in this direction, but I end up 100 meters on the negative side. So I end up over here where this is 100 meters on the negative side of my starting point. So it means I turned around. Went out a certain point, and then I turned around and I came back. So the next question right here, where I got this delta S without a vector symbol over it, that's asking for distance. What is the actual distance traveled? I had a sensitive enough odometer in order to that measured in meters. How far did that actually change? So, to know the distance traveled, I need to figure out, well, how far did I travel to the right? How far did I go when I stopped? Because I have to stop. In a one-dimensional problem, if I turn around, I have to stop. It's impossible, unless there's a rip in the space-time continuum, and that's well beyond the scope of, well, pretty much any physics course. So, let's just concentrate on just this little segment right here, from start to stop. Not to the end of the problem, but just the stopping. At what time did the car stop? Yes. As we go back to our chart here, 1, 2, 3, that was 10, 5, 0. That's the stopping point right there. So in 3 seconds, I'm going 0 meters per second at 3 seconds. For those first 3 seconds, what's my average velocity?
.5 meters per second.
Did you add up all 4 numbers or just the first and last?
First and last.
Okay. So on average, I'm going 7.5 meters per second for 3 seconds. So how far do I go? If I'm going 7.5 meters per second for 3 seconds, or how would you find it?
7.5 times 3. 7.5 times 3.
Yep. Which is 22.5. I'm looking at you like you're the only one with a calculator.
Yeah, it's 22.5.
Okay. So from here, from the starting point to my stopping point, I go 22.5 meters. I know I end up 100 meters to the left of where I started. What was the total distance traveled? Say it again.
122.5 meters.
Ooh.
100. Wait, I want to do that right.
You skipped a segment.
145 meters.
Yes. I went 22.5 meters to the right and stopped. I had to go 22.5 meters to get back to where I started, and then the additional 100 meters to end up where I ended. So it's 22.5 plus 22.5 plus 100.
I'm confused.
Yes.
You lost me at the 7.5. I'm lost after that point.
Oh, good with 7.5?
Yeah, how did we get 7.5?
She told me. Unfortunately, you use that on a test. That's a different implication. So, I know that I start out at going 15 meters per second. That's at time is 0, time and velocity. At time is 0, I'm going 15 meters per second. I travel in the positive direction until I stop. Once I stop, I then start traveling in the negative direction. So the first question I ask is, at what time did I stop? So when time is equal to 3 seconds, my velocity is 0 meters per second. You can pull that from the chart. There are other ways of doing it, but that's the way we did it here.
That makes sense.
So the question I asked was, how far did we travel in the positive direction? And so I went through the similar exercise that we did in order to get that negative 100 meters. First, what is the average velocity? It's just the average of those 2 numbers. That's where the 7.5 came from. 15 plus 0 divided by 2.
Okay.
And then the question is how far? Well, I traveled 7.5 meters per second for 3 seconds, on average 7.5 for 3 seconds. And so you just multiply 3 times that.
Okay.
And that's 22.5 meters.
Okay, I see. I just have to do the math myself.
Okay. And then the question is, what is the total distance traveled? Well, 22.5 meters to get to the stopping point, 22.5 meters to get back to the starting point, and then 100 meters to get to the final point, because I end up 100 meters from where I started. So 22.5 plus 22.5 plus 100. So the total distance traveled, 145 meters.
Yeah.
And then the last question of average, oh, sorry, before I get to average speed. Are other questions at this point? Ariana?
Is this all part of the same question, or did you start on a different question?
That's still the same scenario.
Okay.
There will be, if you look at the old test, you'll notice that there's 6 or so questions that are all, I give a scenario and then I ask the bits and pieces.
Yeah.
So my average speed, average velocity is displacement divided by time. Average speed is distance divided by time. We're dealing with a scalar here. Notice there's no vector symbol over this telling me we're dealing with a scalar. So average speed is just the distance divided by time. Well, you just found the distance. So whatever you got for that previous part, I'm assuming you're going to take that number right there and divide by how much time was taking place. 10 seconds. And you get 14.5 meters per second. Now, there are a couple other questions that I sometimes ask. Sometimes I ask, what's the change in velocity? That's if I give you initial velocity and final velocity. Ask, what's the change in velocity? More recently, not necessarily the ones that tests that I've posted, but more recently, I've also done, at what time did the object stop? I think the last semester or the semester before that, I threw in another question of, what was the distance traveled from the beginning of the problem to when it stopped, to when the car stopped or object stopped? Just intermediate steps that we're doing here. I just didn't explicitly ask for it here. All right, questions? All right. Any other questions from chapter 3 so far?
The airplane example on page 51.
Yes?
Can you explain it?
All right, another addition of vectors that so the wording is, you got 80 kilometer per hour velocity of the plane. Wait, surely they give, there we go. Flying due north 80 kilometers per hour relative to the surrounding air. That sometimes just called airspeed, or there's other types of wording. It's that if the air were not moving at all, if the air were perfectly still, how fast would the plane be going? So that is 80 kilometers per hour. They throw into it a wind velocity that is blowing the plane off to the side. They assume that the plane will move it off to the side at the same speed as the wind. Let's check the wording. It's called a 20 kilometer per hour crosswind that blows it off the intended course. Now, you can debate whether it's going to go exactly the same speed as the wind off to the side, but the intent is, there's a wind blowing it that way at 60 kilometers per hour. So then it asks what's the actual speed of the plane, I believe. And this is vector addition. There are videos where I do it in terms of displacement, there are ones I do it in terms of force. Here, we're doing it in terms of velocity, I just need to add these two vectors. Now, what I typically do is the head to tail method. I draw my 60 kilometers per second this way, plus my 80 going that way. That's kilometers per hour, not second. Kilometers per second would be way too fast. And so my sum, there's my resultant right there. At the right angle. We're dealing with the right
Okay.
triangle, Pythagorean theorem.
Okay. I didn't think that problem had anything to do with
Ah.
that. So great.
Now, I will say the way that he's drawn it here, Hewitt only adds two vectors at a time, I believe. I don't think there's any case where he does more than two. So he does the parallelogram method of adding vectors, where he draws basically a box where these two sides are defined, and then the sum is the diagonal. It's the same thing, because it doesn't matter the order in which you add. I started out with 60 and added 80. I could have started with 80 and then added 60. It gets you to the same spot. Parallelogram method is fine as long as you're only dealing with two vectors. Once you throw in the third one, it becomes way too cluttered. And non sequitur, it won't matter how much you try, how much I try, there's always still dog hair in the mask. Let me go deal with that.
I don't understand any of this.
Sorry about that. Other questions from chapter 3? Brianna?
While we're here, I haven't read chapter 3 completely. I'm very confused about 16. Is that something you think once I'm finished reading it, I will be able to answer?
16 from the master set?
Yes.
I don't remember which 16 was.
It was the box sliding and different formats to show all of that.
Yeah, I was hoping to be able to get to a problem like that
Okay,
today.
okay, cool. Because I was very confused, but I haven't finished reading, so I didn't know if that was something I could figure out on
Yeah,
my own.
that you would have to look at the videos and some of the documents I did.
Okay.
Hewitt does not go to that level of detail. All right. Any other questions before I start to tackle Brianna's question?
I mean, I have a quick one about flash knowledge from chapter 2.
Right?
Why did you want us to learn anticubital and popliteal?
So we wouldn't be stupid.
Oh, my mom. She drilled it into us what the popliteal was and the anticubital, and she felt that everyone should know that. So,
That
This is
answers
for
my
her.
question.
my one acknowledgement of biology right there. Anyone else? But it is fair game for a test question, even though it has nothing to do with physics. All right. When you're dealing with the signs, and the more complex problem that Brianna was talking about, when you're dealing with the signs of our vector quantities, it deals with direction. Now, position, relatively simple, probably essentially the simplest of them all. I'm gonna declare this to be 0 or the origin. I'm gonna say to the right is positive because I'm brainwashed. So right now, my position, positive, negative, or 0.
Negative,
Why?
because you're on that side,
Of,
your starting point.
no, not the reason.
At 0.
Of 0. Position deals with where am I relative to origin or 0 or whichever one you're dealing with. Apparently more dog hair. All right. So right now, what is my position?
Positive.
Positive,
Yep, because I'm on the plus side of 0. And now,
0.
now we got potentially a parallax here, because if I'm standing too far away from the board, from Noelia's point of view, I'm on the positive side, and from Hope's point of view, I'm on the negative side. Just, if I'm somewhere around here, I'm supposed to be at 0. I'm gonna make this my starting point. So no matter what else I do, I pretend I've started here. So right now, what is my position?
Positive.
Positive, 0.
What is my displacement?
Negative.
Because I'm on the negative side of where I started. Position,
Negative.
displacement,
Negative.
position,
Positive.
because I'm on the plus side of 0, and
Positive.
for displacement, because I'm on the plus side of the starting point. Velocity cares about which direction I'm moving. So my velocity right now,
0.
yes,